On to limiting reactants. Limiting reactants is probably one of the more difficult subjects for most people to grasp in undergraduate chemistry, or even general chemistry, I should say. But it's really not that hard, because you all have already been doing this type of concept in class for some time. We're just going to extend it a little bit further. So here we go. We're going to make fruit baskets. In this fruit basket you need 5 apples, 4 oranges, and 3 bananas to make a fruit basket. That's it. That's the definition of the fruit basket. So see how I'm doing that in chemical terms? Okay, so you go to the store, and what you find is you come home with 25 apples, 40 oranges, and 20 bananas. That is not the perfect ratio of all these 3 guys. So something's got to give, and somebody's going to be, you're going to be out of one thing before you're out of other things. You do this all the time when you cook, when you make sandwiches at home, when you even ride your bike, because there's 2 wheels on a bike, right? Okay. So here's what the math would look like. Say I have 25 apples. One fruit basket is 5 apples. I can make 5 baskets with that. What we do in this sample here is we assume that we have as many of the other stuff as we need, and we say how much could we make if we just had this many apples. Then we move on to the next ingredient and we do the exact same thing. So here we have 40 oranges. One fruit basket is 4 oranges. I can make 10 fruit baskets with that. And if I have 20 bananas, one fruit basket's 3 bananas. I can make 6.7 fruit baskets with that. Well, apples is what we call the limiting reagent, because we can only make 5 baskets, and then we have to stop, or yes, we have to go back to the store. That would be a different equation though, right? So in truth, I can make 5 baskets and 5 baskets only, because I can only make enough of what, I can only make as many fruit baskets as the least number of my ratio would go. So this customer specifically wants this ratio. We can't change the ratio. That doesn't change. What we do change is how much of this stuff we can make. So basically what happens is we run out of this first. That's our limiting reagent. We have excess of oranges. We have excess of bananas. And by the limiting reagents, I mean that the apples are what's limiting, okay? So we can do this with the math that we were discussing the other day. So say that you have an equation. First things first, you absolutely must deal with a balanced equation. So we got to balance this equation. So N2 plus 3H2 equals 2NH3. Let's say you have a problem. You have 12 moles of N2 and 40 moles of H2. How many moles of NH3 can you make? Well, see how I'm doing this exactly like I did the last one? I have 12 moles of N2. I use my molar ratio and say, that would give me 24 moles of NH3. If I start with 40 moles of H2, see how this ratio is 2NH3 to 3H2? I get 26 moles of NH3. So the one that's the least, going to make the least amount of product is my limiting reactant. So that means that the N2 is my limiting reactant. And that means that I could only make 24 moles of NH3. Okay, now let's try a more difficult one. Let's say you start with 20 grams of N2 and 30 grams of H2. That means we have to go back on that train that we were on last time. For each of these, we have to go grams, molar conversion, grams. And what we do is we run through both of those just the same way we did when we had moles. Yes, it's a longer type of a calculation. You can totally do it. Okay? So here we go. Oh, I'm going to find out my molar mass of everything first, so that way I have that at my disposal. Okay. 20 grams of N2. And then there's the molar conversion. Okay. Okay, so you do that by getting your molar mass, so that's where this came from. Now we go from moles of NH2, or sorry, N2 to NH3, and then we do our molar mass of this guy. That's 3 grams of NH3 is how much you could make with 20 grams of N2. One thing to point out here, make sure that you're using the right conversions, okay? So I start with N2 grams. I go from grams of N2 to moles of N2. I need to figure out how much NH3 I can make, so we need the molar relationship between N2 and NH3, so that's where that comes from. And then NH3, you have to have the molar mass of NH3 itself. Okay. On the other hand, if we start with 30 grams of H2, molar mass conversion gives you moles of H2, and from here you convert moles of H2 to moles of NH3. Sorry, I said 2, that's 3. And then the molar mass of NH3 here is used to give 169 grams of NH3. Now it's certainly true that this is a much smaller value than this is of NH3. So that means that our limiting reagent, go back to the beginning, is N2. Therefore we can only make 24.3 grams of NH3. Now, we're going to have excess of H2. Let's say that you walk into the lab and you find that you only made 16 grams of NH3. We can figure out the percent yield, because in reality, like when you're baking a cake and stuff like that, things stick to other stuff. You don't get everything into the pan. And in the lab it's the same way. You lose some stuff to beakers and to spillage or whatever it may be. And so you sometimes need to figure out your percent yield. How much of it do you actually make in comparison to how much could you have theoretically made? Well, in theory, we could have made that 24.3 grams. But what we found is that actually, we got 16 grams. So it's real simple to figure out a percent yield. You just do actual yield over theoretical times 100%, and bam, there you go. Thank you much.